Welcome to the presentation on quadratic inequalities. Before we get to quadratic inequalities, let's just start graphing some functions and interpret them, and then we'll slowly move to the inequalities. Let's say I had f of x is equal to x squared plus x minus 6. Well, if we wanted to figure out where this function intersects the x-axis, or the roots of it, we learned in our factoring quadratics that we could just set f of x is equal to 0, right? Because f of x equals 0 when you're intersecting the x-axis. So you would say x squared plus x minus 6 is equal to 0. And you just factor this quadratic. X plus 3 times x minus 2 equals 0. And you would learn that the roots of this quadratic equation, of this quadratic function, are x is equal to minus 3 and x is equal to 2. Now how would we visualize this? Well, let's draw this quadratic function. Those are my very uneven lines. So the roots are x is equal to negative 3. So this is right here. X is at minus 3, y is 0. By definition, one of the roots is where f of x is equal to 0. So the y, or the f of x axis here is 0. The coordinate is 0. And this point here is 2, 0. Once again, this is the x-axis, and this is the f of x axis. And we also know that the y-intercept is minus 6. This isn't the vertex, this is the y-intercept. And that the graph is going to look something like this. Not as bumpy as what I'm drawing, which I think you get the general idea if you've ever seen a clean parabola. It looks like that, with x minus 3 here and x is 2 here. Pretty straightforward. We figured out the roots. We figured out what it looks like. Now, what if we, instead of wanting to know where f of x is equal to 0, which is these 2 points, what if we wanted to know where f of x is greater than 0? What x values make f of x greater than 0? Or another way of saying it, what x values make this statement true? X squared plus x minus 6 is greater than 0, right? This is just f of x. Well, if we look at the graph, when is f of x greater than 0? Well, this is the f of x axis. And when are we in positive territory? Well, f of x is greater than 0 here. Let me draw that in another color. Is greater than 0 here, right? Because it's above the x-axis. And f of x is greater than 0 here. So just visually looking at it, what x values make this true? Well, this is true whenever x is less than minus 3, right? Or whenever x is greater than 2, right? Because when x is greater than 2, f of x is greater than 0. And when x is less than negative 3, f of x is greater than 0. So we would say the solution to this quadratic inequality, and we pretty much solve this visually, is x is less than minus 3, or x is greater than 2. And you could test it out. You could try out the number minus 4, and you should get f of x being greater than 0. You could try it out here. Or you could try out the number 3 and make sure that this works. And you can just make sure that you could, for example, try out the number 0 and make sure that 0 doesn't work, right? Because 0 is between the two roots. It actually turns out that when x is equal to 0, f of x is minus 6, which is definitely less than 0. So I think this will give you a visual intuition of what this quadratic inequality means. And now with that visual intuition in the back of your mind, let's do some more problems. And maybe we won't have to go through the exercise of drawing it, but maybe I will draw it just to make sure that the point hits home. Let me give you a slightly trickier problem. Let's say I had minus x squared minus 3x plus 28, let me say, is greater than 0. Well, I want to get rid of this negative sign in front of the x squared. I just don't like it there because it makes it look more confusing to factor. So I'm going to multiply everything by negative 1. both sides. So I get x squared plus 3x minus 28. And when you multiply or divide by a negative with any inequality, you have to swap the sign. So this is now going to be less than 0. All right? And if we were to factor this, we get x plus 7 times x minus 4 is less than 0. So if this was equal to 0, we would know that the two roots of this function, let's define the function f of x. Let's define the function as f of x is equal to, well, we could define it as this or this because they're the same thing. But let's just for simplicity, let's define it as x plus 7 times x minus 4. That's f of x, right? Well, after factoring it, we know that the roots of this, the roots are x is equal to minus 7. Excuse me, my throat is dry. I just ate too many almonds. And x is equal to 4. Now what we want to know is what x values make this inequality true. If this was inequality, we'd be done. We want to know what makes this inequality true. And I'll give you a little bit of a trick. It's always going to be the numbers in between the two roots or outside of the two roots. So what I do whenever I'm doing this quick on a test or something, I just test numbers that are either between the roots or outside of the two roots. So let's pick a number that's between x equals minus 7 and x equals 4. Well, let's try x equals 0. Well, f of 0 is equal to, we could do it right here, f of 0 is 0 plus 7, whoops, times 0 minus 4 is just 7 times minus 4, which is minus 28. So f of 0 is minus 28. Now, is this is the function we're working with. Is this less than 0? Well, yeah, it is. So it actually turns out that a number, an x value between the two roots works. So actually, I immediately know that the answer here is all of the x's that are between the two roots. So we could say that the solution to this is minus 7 is less than x, which is less than 4. You could have done it the other way. You could have tried a number that's outside of the roots, either less than minus 7 or greater than 4, and have tried it out. Let's say if you had tried out 5. Try x equals 5. Well, then f of 5 would be 12 times 1, right? Which is equals to 12. F of 5 is 12. Is that less than 0? No. So that wouldn't have worked. So once again, that gives us a confidence that we got the right interval. And if we wanted to think about this visually, right, because we got this answer, when you do it visually, it actually makes, I think, a lot of sense, but maybe I'm biased. Let me erase this real fast. If you look at it visually, it looks like this. Oh, whoop, that's way too fat. Let me do it on a skinnier pen. If you draw it visually, and this is the parabola, right? This is f of x. The roots here are minus 7, 0, and 4, 0. We're saying that for all x values between these two numbers, f of x is less than 0. And that makes sense, because when is f of x less than 0? Well, this is the graph of f of x, right? This is f of x. And when is f of x less than 0? Right here. So what x values give us that? Well, the x values that give us that are right here. I hope I'm not confusing you too much with these visual graphs. And you're probably saying, well, Sal, how do I know I don't include zeros? Well, you could try it out, but how come I don't include the roots? Well, at the roots, f of x is equal to 0. So if this was this, if this was less than or equal to 0, then the answer would be negative 7 is less than or equal to x is less than or equal to 4. I hope that gives you a sense. You pretty much just have to try a number in between the roots and try a number outside of the roots, and that tells you what interval will make the inequality true. I'll see you in the next presentation.